6. Recursion tree for Mergesort. The last video of this part. All right. First, still our goal, we want to prove we have T of n is in the big theta of n log n for the general case. Not just power of 2, for the general case. All right. We use the recursion tree to do it first. We did that before, right? Yeah. From the recurrence equation, we use two parts. Recursion terms, we draw a tree. Non-recursion term, also we need to, calculate the total cost. Here, I split into two trees. Okay, one using recursive terms, T of n split into two T terms, and the non-recursion part I put here. Okay, yeah. So that part later we need to accumulate all the cost to get a total cost. Yeah. All right. This part we need to estimate how many levels can we split down to the bottom. Okay. All right. Suppose we have a general n number greater than 2. Then we can find some integer k such that 2 to the k less than n less than equal to 2 to the k plus 1. We can always do that. So that means the given n is between 2 adjacent power of 2. 2 to the k plus 1, 2 adjacent power of 2. Yeah, we can always find that. Okay. Then we can estimate k between log n, log base 2, here lg, we mean log base 2 of n minus 1 and log n. Okay, yeah. Then the number of levels in the recursion tree, k plus 1. K plus 1, yeah. Okay, yeah. Then this side, non-recursion part, also k plus 1. Then each level total cost n, this level n. So each level costs the same n, but we have this many levels. Plus 1 can be dropped, right? Plus 1, not important, we can drop it. So then the cost, we can write big theta n log n. That's what we want to prove. Yeah. Recursion tree, we can show it. This is the general case. Yeah. All right. Then another case, another method we can do using smoothness rule. Smoothness rule, we can also get the same result. Yeah. But smoothness rule, many of you are not familiar with. Yeah. Smoothness rule here, let me write it another time. Eventually non-decreasing function and f of n smooth. F of n, the growth function we use to measure T of n. Eventually non-decreasing function. Then we have the condition T of n belongs to big theta of f of n for values that are power of b greater or equal to 2. Then T of n belongs to big theta of f of n for the general n. General n. That's what we need, right? But the key condition is, the smoothness condition, f of 2n belongs to big theta of f of n. we need to verify this condition. If this condition is true, then we can apply the smoothness rule. Here, our f of n equals n times log n. Log base 2. Yeah. So now let's check this condition. Yeah. F of 2n equals 2n times log n 2n, right? Log of 2n equals 2n times log n plus 1, right? Plus 1. This 1 can be ignored, right? Too small, can be ignored. So constant 2 here, log n, can we say this is contained in big theta of n log n, right? No problem. Yeah. So it is true. If it is true, we can apply this smoothness rule to get the general result. That's another way to do it. But you need to be familiar with the smoothness rule, especially the smoothness condition check, how to check it. Yeah. All right, so the last thing, I want to go through the divide and conquer view for Mergesort. In a Mergesort, if we look at from the divide and conquer point of view, divide step, it is low cost. It is of low cost, big theta of 1. Split in the middle, that's very easy, low cost. Okay. Then conquer step, recursion. Recursion, yeah, automatic. Yeah. Yeah. So we don't need to worry about it. Yeah. The last step, the merge step, the relatively high cost, big theta of k. Big theta of k. Yeah. K means the total data size. So let's consider the total data size, big theta of k. Yeah. So with this view, so if you look at merge sort from divide conquer point of view, you get this kind of properties. Yeah. All right, so let me stop here and finish the whole part D of this module 4. Yeah. All right.